theology and quantum physics. I will flip our slide here, theology and quantum physics. This, friends, is an exciting panel. My name is Dr. McQueen. I know most of you. And this is, I was thrilled when we got the submission that we're about to talk about for the conference. I was over the moon because we, in the 12 years that the conference has happened, to my knowledge, we've never had a paper on physics. So I was really excited for us to broaden the scope of the discussion. It also will give me a chance to talk about something I'm interested in but don't know enough about, maybe to make some embarrassing mistakes in public. But more importantly, it's going to give you a chance to hear from Riley Short. She is our main panelist here. Riley is a senior here at NU. She's studying cellular and molecular biology. So this is, appreciate for a moment kind of how amazing this is. She's studying biology, and yet she has this side hustle in quantum physics, right? So that's pretty brainy. So we're very excited. This is going to work a little bit differently from the other panels. We're going to have, Riley and I are going to have kind of an introductory discussion for maybe 5-7 minutes or so. Mainly so that Riley can help me understand quantum physics better. And as she helps me understand quantum physics better in this discussion, maybe you will start to understand quantum physics better. And maybe that 5 or 7 minutes of understanding will then translate into understanding about 50 to 60% of her paper. That's kind of what we're aiming for. So it's to give all of us just a little bit of grounding before she gives her paper and hopefully make it intelligible to those of us who don't have a quantum physics side hustle. And then after the paper, Riley and I will talk a little bit more about the theological implications of quantum physics. It's actually quite fascinating to wonder about philosophical and theological questions in relation to this topic, and hopefully that will become apparent as we talk. And then there'll be some time for Q&A, where all of the people who I'm looking at Greg Spiritus in the back. You can correct us, Dr. Spiritus. You can sort, not correct Riley, but you can sort me out too in the Q&A. But yes, I'm gonna come over here because this is conversational. I feel like we should have a fireplace or something, and we're going to have a little chat about quantum physics. So Riley, I'm gonna ask you a crazy and impossible question in just a second here. What is quantum physics in 3 or 4 minutes? Can you start to explain? I'm gonna ask you that question in just a second. But before we get there, and I'm going to keep this short so I don't expose too much of my own ignorance, but when we're talking about the quantum level, we're talking about a very tiny, minuscule world. This is kind of the smallest realm of reality that we can inquire into, right? So we're going from the macroscopic world that we exist in. You get down to the molecular level, and beneath that there's the atomic level. And then we're pressing still further into these subatomic realms, right? You can recall this from maybe a chemistry class, or maybe you've taken a physics class, right? Protons, neutrons, electrons, right? And even deeper than that, like quarks, gluons. Okay, now I'm gonna stop talking because here's where I'll sound stupid. But so when we get down, Riley, when we get down to that level, some really strange things start to happen from the perspective of our macroscopic world that we would not expect to happen. So can you take us into that strange realm, the quantum realm, and talk to us a little bit about why it's so weird?
Sure, yeah. So I want to give some context before jumping into this context, even as I have been studying this casually for about 2 years, and I still don't understand it, so I may fumble through it and I may say the wrong thing because it's very nuanced. So I have notes to keep on track, but just want to say that this is complicated, and it might sound very complicated because it is. So I think the easiest way to get into what quantum physics is talking about how it emerged, because this is a fairly new field. Particle physics is new since the 1900s, early 1900s. And it all started with this scientist named Max Planck, who discovered that there is this thing called quanta, which is when energy shows up in little bundles. Quanta or quantum just means like discrete bundles of something, of energy in the case of Max Planck. So what he found was that when heating up an object, it emits energy only at certain levels, which is astounding because in normal life at this scale, things are continuous. Like if you think of the projector right now, it is shooting straight from the projector to the wall. It is a continuous wave. And that's how light works, is it goes from there to here. And it would go further if there was no screen here. However, when you get down to subatomic quantum realms, it doesn't behave quite the same way because they're so small. The particle nature sometimes is evident. And so what will happen is as something is heating up, it will only show up in certain levels. Like imagine a star heating up. It goes from red to orange to white to blue, and those are very distinct energy levels. And correct me if I'm getting too technical or confusing. Okay.
I'm learning.
Okay, cool. And so he found that he found this constant through complex mathematics that I'm not sure how to do, but he found a constant that explains how to get from level 1 to level 2, etc. It's not exactly as simple as that, but that's what I'm going to call it. So he realized that at the particle level, things are discrete. So it's like saying, I have 2 dogs at home. Millie and Cooper are their names. I have 2 of them, and even though they're different, they're just 2. I don't have 2.75 dogs. I don't have 1.5. I have distinctly 2 things. So packets of energy quanta are distinctly 2 with no transition between them, unlike in the macro scale where we see things as being more continuous.
So let me slow down there because this is really important, right? So we, like you said, I just want to repeat that a little bit. So there's all kind of things that we experience as waves, right, in the macroscopic world. And you stop me if I'm getting this wrong.
Particles.
Or like light, or the sound coming from my voice, we experience like a wave.
Yes.
And then other things, I brought a rock. My daughters pick up rocks. So like we can think of this as like a particle. That's really easy to think, like, okay, that's a thing, and then like light is like a wave, and this is like a particle, and they're 2 different things. You're a wave or you're a particle. But it gets really strange because when we get down to the level of the quantum level, things that we would think would be waves have this weird particle-like nature. Like you said, it's like 1, 2, 3, not like a continuous flow, right? Like if I'm like turning the stereo up, I can like think of it like a continuous like hill up, but at the quantum level, it starts to look like stairs.
Mm-hmm.
Like
Stairs except for no intermediate.
no intermediate. Okay,
Whatsoever.
okay, good. So this is maybe where my pea-sized brain when it comes to this is like so I get this. There's the waves, there are particles, they're separate in the macroscopic world, or they seem separate. We get down to the level of the quantum and we realize it's not that simple. It's actually a lot fuzzier that waves can behave like particles and particles can act like waves, and what's going on? Okay.
Yeah, exactly. And so exactly like you said, it went even further from Planck's idea. Einstein won the Nobel Prize for saying that light behaves as a particle. Because in that example, with the projector, it is like a wave. And matter here, like this table, seems very much like a particle. It is solid. My hand's not going to slip through it. I'm not going to slip through the floor. It seems very much like particles. However, matter is actually a wave, and light can actually be a particle. So it's the big mystery of quantum mechanics is how does something decide to be a wave or a particle, decide as if it has consciousness, which one to be, and it really depends on which you're looking for and what you're trying to measure, which seems absurd because that seems as if the quantum observer is changing reality itself, which is very strange because it puts the human mind in such a high importance as if there is no reality outside of our own observation. But what's really happening is that at the micro scale, they have so small a mass that the wave nature, is dominating. At our micro scale here, the particle nature is dominating. However, both still exist simultaneously. So it's as if it's both at once, but neither at once. And it is incredibly complicated. And it brings into context to if we are observing it and it seems to change it, how? How are we affecting reality in that way? Like, why is it when I'm around, the table is a particle, and maybe mysteriously when I'm not, the table is a wave. So that is like the big mystery of quantum mechanics.
Yes. So can I ask another question here? Kind of, yeah, fill in a little. Okay, so when we get down to the quantum level, you'd think like, okay, this is like I'm looking at, in chemistry class, your prof holds up we got the nucleus, protons, neutrons, electrons, right? Okay, like when we go down to measure at the quantum level, underneath the atomic level, we should be able to kind of locate these things, right? But it's really strange. Like you have this sense of what should be particles can kind of exist in a wave-like form. We don't know how to locate them. We don't know how to measure them. We don't know how to, I think it's called state, right? What they're doing, what a particle is kind of doing in state. You'd think you'd be able to kind of articulate its state, but things seem, again, there's this wave nature that makes it very difficult to articulate something's state until you try to measure for it. And this is what's strange. Am I correct here that a subatomic particle could be, we don't know where it is until we go to measure it, and it's actually not where it is until we measure it. Once we measure it, it snaps into a determined position.
It seems
Yeah,
that
it
way.
seems like
Okay.
it's
So
all.
I'll add on, it seems like that because of a rule called the Heisenberg uncertainty principle, which is you cannot know with equal probability where an electron is, for example, and how fast it is going. Seems as if they are like mutually exclusive. So what you can know is the probability of both, but again, you can't know 100% probability of where it is and 100% probability of how fast it's moving.
Until you measure it.
No, you
At
can't
all?
know,
Okay.
ever.
Okay, ever.
Yeah, and
Okay.
experimentally, you cannot know it whatsoever.
Okay.
And so it's like, how does the particle decide? How is it not in one place? And how do you not know how fast it's moving? It's like incredible that you can't measure it, and it's not a limit of our technology. It is fundamental to existence.
Okay.
Yeah.
So talk to us now then about, so we've got this idea of the wave-particle duality, which makes the quantum level very strange. And then we have the notion of wave collapse. Can you explain wave collapse to us a little bit? Because this is what will get us to your paper. The wave collapse and the idea that there's a need for an observer for this thing called wave collapse to happen.
Yeah, so wave collapse means that you're looking at a quantum state, which is just a mathematical description of a physical system. So a very loose analogy is like, my name is Riley, I'm sitting right here, I'm in HSC and I go to school here. That is like the context of my state of being. So a quantum state has many options that it could be, potentially infinite options, but until you measure it, it seems as if it is simultaneously in all of those states or none of them until you pick what you're measuring, and then it sort of collapses into one single point, if that makes sense. So it's kind of like it exists as a wave, but when you measure it, it's a single thing that you can look at.
And that's so weird because
Yeah.
it's the measuring, it's the observation that seems
Yes.
to kind of snap it into whatever it's doing.
Yeah, and to like tell you how weird this is, a great example is Schrodinger's paradox, which he tried to explain how this was weird because technically it sounds like just mysterious and scientific and as if it might be just a law. But Schrodinger's cat is an example of, imagine putting a cat in a box with a setup that an atom might decay or it might not with equal probability. And you don't know which one it's going to be, and you can't know until you open the box. And because it's 50% chance the cat is dead, 50% chance the cat is alive, it seems as if the cat is held in this suspended state of being both dead and alive at once, which is absurd on the micro scale because a cat in our reality can't be both dead and alive. Or another good example is I talk about in my paper, is imagine putting bacteria in a box and you strike it with a cosmic ray and it's either going to mutate or it's not, but you can't know until you open it. So if the observer is needed to actualize an event, it seems as if the bacteria in whatever span of time before you check it is both mutated and unmutated. So it is a huge mystery of when does a wave decide to collapse? And decide, again, loosely because it's not deciding, but that is what it seems like. So my paper, I try to avoid all of this confusion by saying that the consciousness and the mind is not needed for observation, and that instead any interaction between states is what's important. So it is the relationship between states that actualizes events and collapses the wave function instead of needing a mind.
Yes, good.
Yeah.
Let me say one last thing before you read. So this paradox, she's going to talk about this Schrodinger cat idea, which if you're a cat lover is just rough. You have an unstable atom, right? And it could decay, and you have something in this box with the cat that can measure whether this decay is going to happen or not. But because of the because of what is it, quantum indeterminacy?
Yeah.
Is that because of quantum indeterminacy, it seems like you could have two states at once. You could have it both doing something and not doing something. And the idea was to put in some kind of instrument that could measure what the atom was doing. And if it did one thing, poison would be released and would kill the cat. Like I said, sorry, cat lovers. Schrodinger apologized too, I think. So the poison would be released if something happened, and if it didn't happen, the poison wouldn't be released. But because of the indeterminacy, it would seem like the poison could be released and not released, and therefore the cat could be dead and alive at the same time, which Schrodinger says that's crazy, and it wouldn't be one or the other until the observer opened the box and saw, just to kind of paraphrase again,
Yes,
right?
exactly.
And so as I take it, you're trying to suggest, okay, this seems totally problematic. This isn't how science works, right? There needs to be a way of talking about states in a more solid way that doesn't involve human consciousness having to actualize them, right? And so you're going to propose how that could be, maybe at one point so this is for you cat lovers, at one point in the paper, I think you suggest that maybe the cat's consciousness could be kind of actualizing things,
Not even that it's consciousness, it is a state.
or there's a state. Yes, it's in a state, and any other kind of state is going to actualize these indeterminacies.
Yes.
Okay, cool. Are you ready? Take a breath. You're getting smarter. It hurts your brain, but you're getting smarter. It's like lifting weights. All right.
Okay.
Go ahead.
Thanks. Okay. Should I move to the podium?
Yeah, go ahead. Go to the
Okay.
podium.
And actually, I kind of want to add a few brief definitions, honestly, before moving forward, because I talk about some specific things in my paper. So I'll just add 3 more, and then we'll be done with preliminary stuff. Actually, just 2. So the first one I want to mention is Hugh Everett proposes the multi-universe theory, the branching universe theory, which is pretty popular in media today, and yet I disagree with how it's portrayed. Anyways, it means that when there is a measurement made, let's say with the cat being dead or alive, he explains it as there are 2 universes where the cat is living and life goes on, and the cat is dead and life goes on for everyone else. So it's 2 mutually exclusive or potentially infinitely mutually exclusive parallel universes, which I try to disprove in my paper. And then lastly, I mentioned the Copenhagen debate, which was when in the 1920s, a bunch of my favorite scientists got together to discuss definitions and pretty much decide how they're going to define this new emerging field. So Niels Bohr was part of it, Einstein was part of it, and they determined that particles exist in all possible states at once, which I try to avoid as well. Anyways, let's actually get into my paper. So this is called A Clarification of the Quantum Observer by me, Riley Short. Quantum theory introduces a paradoxical relationship between mankind and the observable universe. If all matter is quantized, and if all atomic properties can be measured, then all matter must be held in a suspended state until observed by the observer. Schrodinger's thought experiment exemplifies this ghostly nature of atomic particles. This measurement problem of quantum theory seems to imply that the observer, or the mind, plays a crucial role in the very existence of the universe. This traditional view is highly anthropocentric and limits observation to human beings able of making conscious measurements. Following this logic implies that the universe does not exist without a human mind. This interpretation is illogical, and thus quantum theory requires an updated definition of the quantum observer. I propose a 2-fold definition of quantum observation. 1, quantum observation happens when a physical system that possesses a certain state interacts with another given system. One system only has relevance in the way it interacts with other states, and only through this interaction are states or properties actualized. 2, the quantum observer is any physical system capable of maintaining a state that differs from another state. Any physical system qualifies as a quantum observer if it interacts with another state. These definitions change the understanding of the observer-observed relationship and remove the relevance of the mind or consciousness in quantum mechanics. Instead of special observation, which requires consciousness, any physical system can take on the role of an observer. So any interaction of states qualifies as a measurement. This removes the more loose philosophical take on quantum observation, where consciousness is key to reality. Adopting the new definition of observation negates the possibility of an absolute reality outside of interacting quantum states. Values are only valuable in relationship to other states. Qualities are actualized when systems interact, or if there is change relative to a given reference frame, whether those characteristics are spin, velocity, direction, or any observable quality. So all change is relational to a given reference frame, and all actualization of data is relational. This corresponds with Heisenberg's uncertainty principle, which implies that an electron spin is only detectable when it interacts with its environment. The definition of quantum observer proposed in this paper parallels the theory of Carlo Rovelli, a physicist from the University of Pittsburgh. Rovelli claims that a quantum observer is a physical system having a definite state of motion. He also argues there is no observer-observed distinction when all systems are considered equal. The observer versus observed is a false dichotomy, and what matters is the interaction and relationship between states. From this idea, Rovelli distills his idea as an observer having a definite state of motion. However, my proposal varies in that the key feature is simply the difference in interaction between states. If relationship between states is truly key to existence, then there is no observer-dependent reality. Outside of the possibility to interact or difference between states, there is no absolute reality. This stance counters Einstein's hidden variable theory, which proposed that the answer to the measurement problem was due to some feature that mankind had not yet discovered, as if there was a variable not considered. Differences between states and the resulting interactions shape reality. The new quantum observer. In the following sections, I will break down some famous theories of quantum mechanics and how the proposed idea of quantum observation affects each theory. The purpose is not to disprove any theory, but instead enhance or alter the results of each given a new definition of observation and of observer. The first is Schrödinger's cat. Schrödinger's thought experiment outlines the absurdity of the measurement problem in quantum mechanics. The paradox is especially strange when clinging on to the traditional understanding of the quantum observer. The imagined scenario goes as followed. A cat is penned up in a steel chamber, along with the following diabolical advice, which must be secured against direct interference by the cat. In a Geiger counter, there is a tiny bit of radioactive substance, so small that perhaps in the matter of 1 hour, one atom decays, but also, with equal probability, perhaps none. If it happens, the counter tube discharges and through a relay release of a hammer, which shatters a small flask of hydrocyanic acid. If one left this entire system to itself for an hour, one would say the cat still lives. If meanwhile, no atom has decayed, the first atomic delay would have poisoned it. The wave function of this entire system would express this by having in it the living and the dead cat mixed or smeared out in equal proportions. The Schrödinger paradox clearly demonstrates the effect of measurement on a quantum system. If the act of looking inside the box and of observing that collapses the wave function, it is the act of looking inside the box and observing that collapses the wave function. The state of the cat cannot be concluded until after a measurement is made. Another example can be determined by mutating bacteria. Imagine a bacteria is being struck by a cosmic ray and then mutated. Since cosmic rays follow the laws of classical physics, it acts as a measurement. But if the bacteria is considered a quantum system, then one cannot confirm whether the mutation has occurred or not until observed. One could not even consider the species evolved until observed. If the universe exists in a suspended state outside of human observation,
then the mind and consciousness play a role in reality and matter. Consciousness somehow collapses the many suspended states of possibilities into an irreversible quantum state that is called measurement. Unless measured, quantum physics implies reality exists in a limbo state when not observed, at least when adhering to the original idea of the observer. My proposed definitions eradicate part of the mystery of the Schrodinger's paradox because human observation is not required for actualization of properties. Instead, the cat could qualify as a quantum observer, and from its perspective, it is never in superposition. The cat's state may be indefinite in relation to the human observer, but for the cat, its state is always definite. All particles interacting with the cat inside the box, the particles entangled with the cat's fate, are equally definite. Only in relation and from the view of the human are things ever unsure. This navigates entanglement more clearly than believing that the system remains in superposition until viewed by an observer that is conscious, like a human. The mind merely plays a role in interpreting data taken in by the observer and does not have a special role in determining reality. The Copenhagen view. In the Copenhagen interpretation, a system is given actualized values when interacting with classical objects. For example, when a person opens Schrodinger's box to see the cat's fate, when a person opens the box to see the cat's fate, the only information known about reality is what can be measured, and yet measurement affects the system. Classical mechanics also assumes that variables hold value at all times. With my proposed definitions, quantum systems interacting with classical systems, or any quantum state, is what actualizes variables, and they do not hold value until an interaction takes place. The only information to know is relational. Next is the branching universe theory. In 1957, Hugh Everett published a dissertation at Princeton University where he introduced the branching universe theory. Everett claims that when a measurement is made, the observer can exist in different states with equal probability. Each branching possibility leads to non-overlapping alternate realities. All states exist in a superposition until the wave function is collapsed into a single event. This view assumes a traditional idea of the quantum observer, introducing my new idea discussed in this paper, Crumbles-Hughes theory. If things only exist in relation to other states, then there is no existence of an alternate unchosen branch. While each measurement has variable outcomes with different varying probabilities, in the end, there is only one that exists. Only the interaction of quantum states allows reality to exist, which a hypothetical branch would not be able to do. In conclusion, changing the way the quantum observer is defined does not impact the way quantum mechanics is applied, but offers theoretical support for how reality functions. Viewing reality as the relationship between quantum states bypasses some of the philosophical mystery of quantum mechanics, traditional quantum mechanics. The observer is not limited to humanity or those capable of a conscious mind. Any interaction between two states constitutes a measurement. Therefore, any given physical state is an observer and holds equal status as all others. The difference and relationship between states is the key to reality. Thank you.
Okay, so in a few minutes here, we want to tease out some of the implications of this. This is wonderful. I hope this makes you happy. Like this is, this is so great. I was gonna say nothing. Okay, this is so much better than a million meetings that I'm normally in, right? I'm usually in this room. I'm sorry, I'm just gonna say it. There's administrators in the room. I'm usually in this room for meetings, and this is like so much more invigorating. It's wonderful. You don't have to sit in a meeting. Your mind can be alive, right? Okay, so let's talk about this. This is fascinating, Riley. If I understand you right, in layman's terms, you are suggesting that we can kind of get rid of this problem of a conscious observer being necessary to actualize the world, right?
Correct.
So I want to ask you a provocative question, hear your response, and then maybe supply some of my own answer, and you can push back if you want. one way of hearing your paper is that it is kind of trying to drain the universe of consciousness, that we don't need conscious mind to make things happen and actualize, right? There are moments in your paper, though, where when you talk about, say, the cat counting as a consciousness that could be observing the state in the box, and then anything that is in a state kind of operates to actualize other quantum, any state, right? Could you say that consciousness penetrates everything? Could you turn it around and say maybe there's a way that reality down to its very core is mind-like, that it has a kind of, that maybe humans aren't the only, that consciousness isn't just something that exists in the human skull, but weirdly it's in a strange way that thought and ideas are cosmic? Does that sound, that might sound really hippy-dippy, new agey, what's going on? I think I can defend it as not that, but.
Yeah, so I know what you mean, and I don't think that the universe is conscious. I think that it is strictly more objective. However, I don't think that's an anti-spiritual or anti-Christian idea, because we are not needed for creation to exist. It has intrinsic value, whether we're here or not. Just like halfway across the universe, there is some collision going on. Just because I don't sense it, it's still happening, it's still real. And I think that is proven even throughout the Bible of, in the creation story, it is not humans first and then reality. There is the ocean, there's birds, there's plants, and those are actualized with properties before we even take it into account. So you either believe that the universe exists, end of story, or if you still require an observer, I wouldn't, but you could default to saying God is as if he's the ultimate observer, which actualizes things. Although I am more along the lines of things just exist.
Okay, I love this. This is great. Okay, so I want to give us a quick little history here, and you can bounce back at me if you want. Part of the reason why this is such a problem, and you science folks can push back too, but part of the reason by my lights why this is such a problem has to do with the history of Western thought. We've arrived at a moment in Western thought where we think of the universe as a giant machine. It's the mechanistic view of reality, right? This is birthed in the scientific revolution. 400 years or so, we've been thinking about reality this way. It's a giant machine. Machines don't have minds. Machines don't have consciousness. So when you get down to the quantum level and you start to realize, well, okay, this is weird, it seems like we need observation and we need consciousness again, we got rid of all that. It's supposed to be a machine. We can't need consciousness, right? So that's partly what makes this problem, right? I think it would be really interesting to do a little historical digging and go back to what the ancients and the medievals said. I don't want to revive Aristotelian science. Don't worry, you science people. I'm not trying to revive Aristotle's sense of physics. But the ancients had this way of talking about reality that didn't screen out mind and consciousness from all things and localize it only in the human skull. Instead, they said, no, there's something mind-like about the whole of reality. And it gets to our definition of God, too. What God is really interesting after the mechanistic picture. But to be really brief, I just want to say two things. You all have studied Plato. If you haven't, take some more English courses. Plato talks about how ideas and mind are really more fundamental to reality than matter, right? And this sounds bonkers, but think about it. You go into your geometry class on the first day, and the geometry professor says, I'm going to show you a triangle. You've never seen a real perfect triangle in this world that we inhabit. But you have an idea of a three-sided closed shape. And the reason you can perceive, Plato would say, the reason you can perceive triangles here in this world, even though they're imperfect, is because you have an idea. The idea makes this reality coherent. And so for Plato, he wrote over the door of his academy, he said, don't come into my academy, don't come to school here unless you've studied geometry. Because you'll have all your stupid materialist prejudices that matter is the most real reality. But if you study geometry, you'll realize, no, ideas are more fundamental. Ideas give shape to things, give reality to things, okay? So for Plato, mind and ideas weren't localized in the human skull. Mind and ideas were pervasive of everything. The reason I can perceive a coherent reality out there is because that reality participates in some higher idea. My mind participates in that higher idea, and that idea is the meeting place of my mind and the external reality I'm accessing. Does that make sense? So there's a weird way that mind is pervasive of everything. Actualize. My suspicion is, if we were to recover some of that vision, we wouldn't be so nervous about consciousness being necessary for the reality to exist. And I'll say one last thing, and then I want you to push back on me. Yeah. It also has to do with how we think of God, okay? You get to the 16th, 17th, 18th century, and you want to turn the machine, you want to turn the universe into a machine so that you can, control and investigate it, which is very powerful. We put airplanes in the air and we get vaccines and we build projectors because we say we're not going to talk about purposes and spirit and soul. We're going to talk only about matter and material interactions. And this is very powerful. We're going to treat the world like a machine and figure out how it works, right? But strange things happen to mind and God when you make that move, right? You look at the ancients, God, okay, so, let me try to clarify this. So, if the universe is a machine, what role is left for God? He's the dude who built the machine. He's a dude out there who made a machine and pushed a button and it got going, right? This is a disaster. This is a disaster from the view of ancient and medieval thought, okay? The richest Christian and pagan thought would not talk about God that way. A giant dude out there that may or may not exist, they would talk about him like St. Paul does. He's the ocean of being in which we live and move and have our being. They would talk about him like St. John does in the prologue. In the beginning was the Logos, and the Logos was with God. And this wisdom, this reason that permeates all things, that everything shares in this reason and this mindedness, right? And so you end up with an image of God that seems like, okay, he's got to be this guy out there who built the machine, or this guy out there who's like looking at the machine to like actualize the quantum states. And I'm wondering if we went back to a more traditional Platonic, Aristotelian, Augustinian, you name it, all these ancient guys and women, Julian of Norwich talked about God this way. If we went back to that, I'm wondering, God is the ground of being, the ocean in which we live and move, this ultimate mind, this mind that pervades all things, and our finite minds participate in his infinite mind. I'm wondering if that might be a richer way, that he's in and beyond all things, and all things are actualized in and through his mindedness. Does this just sound loopy and new agey, or what's your response? And then we should open it up for Q&A, and we can get sorted out. I can get sorted out by the science faculty.
Yeah, so I'm not a theologian, but what I do want to say is I personally see no problem in viewing the world as strictly objective and strictly mechanistic in the way that you put it, but only because I don't think it's anti-Christian or anti-spiritual, again, to believe that, because science is just a small piece of the puzzle, and we have to put blinders on to things like spirits. Yeah, you have to like narrow that out to make any measurements, to make any ideas, and it's not that you're excluding God from the process, it's that you're trying to focus on the laws that he created, because God put all of the laws of the universe into place in the beginning of time, and they've been constant ever since, and that's why we're able to do science, is because the laws are constant. And so if in our own language we have to call that consistency machine-like, I think that's totally fine, and I don't think it removes God, because God is still above science and above the laws that he created. But in order to look at science, sometimes you have to take out consciousness, which is what I'm trying to do here, is that yes, consciousness is important, and I'm sure all the things you said are important for a full reality, but when it comes to, I'm just looking at science, I don't think it's a problem to see it as just a machine, because it is just laws, like I said.
and maybe I'm wrong in that, or maybe I'm a deist in that, but
I love friends, you just witnessed a real debate. That's great. I love that you actually push back. Okay, we're gonna talk now. Do you have questions? Is your brain like totally like busting out of your skull? Yeah, Katie.
Of all the things that you have...
Say, what was your favorite?
Yeah, what was your favorite part about learning quantum physics? Not what I was going for. No, what inspired you to study quantum physics above all other sciences besides, biology?
Yeah, so that is a good question. So I would explain it as I am very obsessive. And I am obsessed with themes at certain times of my life. And so 4 years ago, I became obsessed with time. And so I was obsessed with time and how absurd it is for about 2 years. I'm still bewildered and don't understand it. Anyways. And so then I began thinking about movement and change, and that became like the big theme. And as I was learning about movement, obviously I got into physics, and through chemistry with Spreetus and physics with Dr. T, I started learning bits and pieces of how the universe worked. And then it was COVID, and so I went to the bookstore and I bought this book on quantum physics because I was like, well, I've got a lot of time. And then in the 2 years that I was back in Alaska for quarantine pretty much, I just went down a rabbit hole. I became obsessed. It started with a book, turned into 5 books, turned into podcasts, to where I would go walking like 4 to 8 miles with a podcast on about quantum theory. I would climb a mountain, sit at the top reading about particle physics. So I think I am inspired only by my obsessive nature. So that's my answer.
That's great. Go ahead.
So it seems that in terms of like Schrodinger's cat, that it's something that because we're not seeing what's happening within the box, it's really easy to just say like, oh, this is probably what's happening inside the box. And so I think that's kind of probably where part of the theory comes from. The original theory is just that we aren't able to observe that, so like what can we say to its current state? How did you go about trying to push back on that? Like that seems like a really daunting thing to try to prove something that one of the prerequisites to its existence is the fact that you are not observing it.
Yeah, so that is a good point, and that is why quantum theory is theoretical and often very hard to have concrete evidence for. So you're asking like how I personally came up with how to disprove that?
Yeah, and just like what's your approach to that, and like if like somebody who like was a huge advocate for that theory, if they came up to you and said prove me wrong, like what's your system of thought for how you're like trying to observe the unobservable?
Yeah, I see what you mean. Well, I think that the point is not that you need to prove it, it's that it's objectively going to happen whether we need to know it or not, because the act of measuring causes interference and seems to affect the system. I think it is a humbling moment for humanity to be like, we may not know, but it still happens. It's not a matter of belief, it is that things happen, things are actualized, whether or not we are there to see it. It's like the whole if a tree falls in the woods, does it still make sound? Like, it still happens. That's the underlying thing. Yeah, I think I pondered that because I don't like, maybe just as a scientist, I don't like it being not objectivable, especially in the field of science. It is supposed to be objective.
And what's interesting, let me know if I'm wrong here, I think Schrodinger didn't like that either. Like he proposed the cat thing because he's like, this is wacko. Like this can't be right. So you're kind of like helping him out with this.
Okay, so I'm super excited about this. I'm particularly really taken by the need for the relationships.
Yeah.
And I love taking the human consciousness out of it. When you read science fiction, I'm always like, okay, but this, like there's sort of this ickiness about that, how anthropocentric, how human-centered it has to be, and I hate the multi-branching universe thing. But I also really loved that idea of, this is what I'm really excited about, like the relational bit, that's key, but then breaking down the observer-observed dichotomy, like I feel like that is so crucial Like that's not, I think it's a science thing, but also it's like a post-colonial thing. And I'm just very excited about that. Were you trying to do some of those things? Are you excited about
Like
those
to break down that
implications?
dichotomy? Yeah, I'm so excited about it. Yeah, like I have been thrilled about this since I don't know if I discovered it or if I observed it. I don't know where the idea came from. But when I thought about how it didn't need to be a binary, I was like, well, of course everyone should think this way. Of course it is like so illogical to set up the dichotomy of observer versus observed. It seems like outdated science to look at it as if like, oh, we're the only thing with purpose, and so things only exist for us, and when we're
I want
there.
to push back on
Wait,
you
wait,
right
wait,
there.
I just wanna say,
okay.
I really feel like, it feels to me like the shift when we went from the Earth is the center of the universe to no, we're rotating around the sun, and like people just have the wrong view, and then if you look at it this other way with this extra information, then the whole thing shifts. Like that's what I feel like.
That's what I feel like too.
Okay, so can I push back here?
Yeah.
Like, so what does that mean to break down the observer-observed binary? Does that mean that this thing is observing me back? That there's no observer, there's no observed, that everything is minded, conscious? Sorry, I'm really pushing on this. Like this non kind of localized dude out there who's watching us, but no, like this participatory sense of consciousness.
Yeah. So I think the answer is that it is another dual nature of reality. Because when you think about it, it makes sense that nature, it has duality within it because God himself has a dual nature, or more like a tri-nature, yeah. And it's not that God is three different gods, or that God, it's just the way that we're interpreting it. And so, what was your question exactly?
So it seems like if you want to break down that observer-observed binary, then you almost, seems to me like you have to move towards something where we can be observed too. Like we're being observed. We're like the thing I'm looking at is weirdly looking back at me. Like you said it has its own purposes.
It does.
It has its own purposes. It has its own.
Yeah.
And it's interesting the metaphorical language we keep sliding.
I was gonna say it's a problem of language.
You keep saying like, oh, but it's like it's conscious, but no, of course it's not conscious.
Yeah.
Like I want to say, so what if we redefine consciousness so that it isn't just localizable here, but it's somehow a property? Can it be a property? This mind-like.
Yeah.
Not that it's a physical property, but some kind of, it has, when you say it has its own purpose.
I would say
I feel like there's a lot of physicists who would be like, I have a beef with that. Right?
That things have intrinsic value?
That things have their intrinsic purposes, like that like an electron or any physical entity would have its own purpose.
I don't even think that things need to have, it is again a problem of language, which is why quantum theory reaches the edge of understanding, because all that I'm trying to say is limited by the words that I'm using.
Yeah.
But I think that all matter has intrinsic value, regardless of purpose.
Yeah.
It is just because God created it, which is a Christian belief, a very Christian bias, so it might be why some physicists would hate it, but it's like, regardless of purpose, especially purpose for humans, it still is valuable. An electron somewhere off in existence still is valuable and still interacts.
Amen.
Yeah.
Amen.
Does that answer your question?
Amen.
Okay.
I 100% agree.
We've got other hands back here, way in the back corner.
Would you say that this kind of new interpretation of the quantum physics, of defining in terms of the relationships between the states, has any empirical or methodological implications for the science? In other words, would the ways that we do quantum physics change because of this idea?
No, not at all. And I think that, I don't mean to sound sharp, but no, I want to clarify, like, this is simply a theoretical framework for mathematics that work out. I am not trying to fix the math or trying to change any of the foundation, just more of the interpretation of some things, very much focused on specifically the philosophical interpretations of quantum mechanics, because quantum mechanics works. Everything checks out mathematically, experimentally, it's good to go, at least as far as it can be right now. Anyways, but my idea is just a framework for when it comes to applying this to human life and consciousness. That's where the distinction that I made
becomes important.
Yeah, Stephen. Go ahead.
Stephen.
So, this is great. Do you find, is this what you found in digging into quantum physics? That like I'm taking like science is very much like founded upon let's not talk about all these like different ideas. Let's just focus on like the bare things and like find the essential laws. When I think what I'm kind of experiencing is like, let's take this as far as it can possibly go and into the very thisness of whatever this universe is. Do you find that like the scientific method in trying to have such a strong, I guess, ontology, like the study of being, like, do you find that like it is struggling, or better yet, like dipping into spiritual things? And I think this is like obviously it kind of comes down to the universe like is what it is, and I'm not going to try to like read meaning into that. That's kind of what this is about. But also, I really wish this came down to a clear question. But I guess it is like beyond just like I guess God is this plus God probably created this. Like, what about you digging into this makes you love God more?
Oh, okay. I would say just because I love to study intricate, complex things, because I think God primarily takes the role of creator in my own view, because that's what I love to study. And so when it comes down to, like, after all of this scientific discovery, we still can't explain the foundation, the very simplest part of the universe of, like, how things exist. I think that points to the existence of God, because it's so impossible that we can't understand it, and yet things do exist without us around. You know, I think it even mirrors the Bible story, like I said, of creation, where because things were created before humans, it makes sense that when we dig into quantum theory, it seems as if the universe exists without us. And it gets into a problem of like, was the world created for humans or humans for the world? I don't know. It depends. Maybe it's both. Maybe it's separate. I'm not sure. But I think that, does that answer your question, kind of?
Yeah. I think I had a follow-up question as you were talking, but I lost it. So
Okay.
It's just beautiful. It's just great.
Well, friends, this is a landmark occasion. We've worked physics into the Faith and Humanities Conference, and it was a stimulating experience. Let's say thanks to Riley again.
I just want to say thanks to Easterling for helping me write this paper, and thanks to Spiritus for helping me prepare for hours and hours for this presentation.
Thank you so much, everybody. We'll take about a 5-minute break. You can grab some food.